Alright guys, today we're going to do Packet Tracer 9.3.1.1, configuring ASA basic settings and firewall using CLI. We're going to start. So first you verify connectivity and explore the ASA. You configure basic ASA settings and interface security set levels using CLI. Configure routing, address translation, and inspection policy using CLI. Configure DHCP, AAA, and SSH. Configure a demilitarized zone, static NAT, and ACLs. Alright, so let's go ahead and get started. Take note of your passwords here. See, this packet tracer activity is not a substitute for ASA labs. Yes, activity provides additional practice and simulates most of the ASA 5505 configurations. When compared to a real ASA 5505, there may be slight differences in command output or commands that are not yet supported in packet tracer. This packet tracer activity starts with 20% of the assessment items marked as complete. This is to ensure that you do not inadvertently change some ASA default values. For example, the default name of the inside interface is inside and should not be changed. Click check results to see which assessment items are already scored as correct. Okay, verify connectivity. The ASA is not currently configured. However, all routers, PCs, and the DMZ server are configured. Verify that PCC can ping any router interface. PCC is unable to ping the ASA, PCB, or the DMZ server. Okay, so we'll start there. PCC. Make sure it can hit any router interface except for the ASA, the server, or PCB. Okay, so we can go ping. Alright, that works. We can go ping 10.1.1.1. Oops. That works. Okay. Yep, okay, so we can ping everything just fine. Okay. So use the show version command to determine various aspects of this ASA device. Okay, so we're going to go to the ASA. Cisco NPA55. No, Cisco NPA55. No, okay. Cisco. It should be Cisco NPA55. What's the deal here? Maybe it's Cisco ConPass. And oh. Alright, admin path. You gotta be kidding me. What? Cisco NPA55. Right? That's what it says. Cisco NPA55. CISCOENPA55. Right? Okay. Enable CISCOPA55. I don't know if this is a joke or what, but it's not. None of the passwords work. Ah, there is no password. Okay. So, just hit enter. Oh. Oh, check it out. You don't even need to do that. I guess you can do a show version from here. Look at that. You don't even have to go into config mode. So you can do show version. Right from the beginning. Alright, so yep, we did show version to determine various aspects of the device. We can see here we're on DMV version 6.45. We're on software version 8.42. System image file is here. Interesting. Yeah, we got Ethernet stuff. VLANs, we've got 3. We've got 8 max physical. Oops. Interfaces. No trunk ports. We've got 10 inside hosts apparently. Alright, interesting. Base license. Cool. Alright, so enter privileged exec mode. Says it right there. Password has not been set. Press enter when prompted for a password. So I should have just read ahead a little bit and I would have known. Enter. Now we're in. Alright, show file system. Cool. We've got one file. So determine which prefixes are supported. Oh, so disk 0 : and flash colon are supported prefixes. Okay. Use the show flash or show disk to display the contents of flash memory. Yeah, so there's our one file. This is not a file, like I said. That's actually something else. I guess that's the partition, basically, where the file system lives. That's how big it is. That's how much is free. That's what type it is. A disk, read and write, and that's what you can call it. Alright, so many ASA CLI commands are similar to, if not the same as those used with Cisco IOS CLI. In addition, the process of moving between configuration modes and submodes is essentially the same. Okay, good to know. Step 1, configure the ASA hostname as CCNA-ASA. Okay, so let's go conft hostname CCNA s-asa. Boom. Alright, 23%, that's good. Configure the domain name. Alright, so IP domain name, no. IP, nope, okay. So just domain name, CCNA security.com. Alright, 25%, that's good. Use the enable password command to change the privileged exec mode password to Cisco NPass with 5s as the S's. So enable password Cisco NPass. Alright. No, that didn't give us any percentage. Did I do that wrong? Enable password Cisco NPass. Cisco NPass. Alright, well, we'll just move on and see what happens. Use the clock set command to manually set the date and time. The step is not scored, so I'll just do it, but clock set hour, minute, seconds, so I'm going to say it's 12, 12, and 12 seconds, whatever. Oh, what else does it want? It wants, oh, day of the month. It's the 12th day of the month of the 12th month of the year, right? We'll say December. No. Okay. What else do you want? Okay, we're going to say 12/12. Nope. 2012. Alright. So I just used 12s because I didn't want to think about it too hard. Clock set. You will only configure the VLAN 1 and VLAN 2 interfaces at this time. The VLAN 3 demotorized zone interface will be configured in part 5 of the activity. Okay, so configure a logical VLAN 1 interface for the inside network. Okay, so interface VLAN 1, name if inside, IP address 192.168.1.1, 255.25250, security level 100. Okay, alright, we're up to 30%, that's good. Interface VLAN 2, name if outside, IP address 209.165.200.226, 255.255.255.248. Security level 0. Alright, 34%. Back up a little bit. Show interface brief. Oh, show interface IP brief. Cool. Looks like we got VLAN 1, VLAN 2. They're up. Good to go. This command is different from the iOS command show IP interface brief. If any of the physical or logical interfaces previously configured are not up, troubleshoot is necessary before continuing. Most ASA show commands, including ping, copy, and others, can be issued from within any configuration mode prompt without the do command, so that's kind of nice. Use the show IP address. Alright. To display information for the layer 3 VLAN interfaces, use the show switch VLAN. Okay. To display the inside and outside VLANs configured on the ASA and display the assigned ports. Okay, so I hope that's right. We'll find out. You should be able to ping from PCB to the ASA inside interface. Okay. So ping 209.165.200.226. No. Oh. What? Oh, ping it. You should not be able to ping it. Okay, so yeah. That's correct. Not working. Configure a default static route on the ASA outside interface to enable the ASA to reach external networks. So, create a quad 0 default route using the route command. Route, no. Conft route outside. We're going to say route outside any IP address in any subnet that you don't know. Send it to 209.165.200.225. Not even that you don't know. It's just any IP address in any subnet. No, that's not. There we go. In any subnet. Send it here. Alright. Issue the show route command. There it is. It knows where this one is because it's directly connected. It knows where this one is because it's directly connected. And this is our static default route where it sends everything that it's not directly connected to, so it doesn't know. Verify that the ASA can ping the R1.0000 IP address of 10.1.1.1. And it works. Be right back. So we pinged this address, it worked. Create a network object inside net and assign attributes to it using the subnet and NAT commands. Alright, so object network inside. Why isn't that working? Inside net. That was weird. Subnet 192.168.1.0. Alright, NAT. Oops, dynamic interface, not interface. Oh, dynamic interface. There it is. And got up to 44. Alright, the ASA splits the configuration into the object portion that defines the network to be translated and the actual NAT command parameters. These appear in two different places in the running configuration. Display the NAT object configuration using the show run command. Okay. Object network inside net is 192.168.1.0. Object network inside net, inside outside dynamic interface. I don't know. I guess that's all we were looking for because there's not much else here. Alright. From PCB, attempt to ping the R1 gig 00 interface. Okay. At 209, 165, 200 at 225. The pings should fail. Okay, looks like they're failing. That's what we need. Issue the show NAT command on the ASA. Okay. Show NAT. Issue the show NAT command on the ASA to see the translated and untranslated hits. Notice that of the pings from PCB, 4 were translated and 4 were not. I guess we were pretty close. 4 and 3, whatever. The outgoing pings were translated and sent to the destination. The returning echo replies were blocked by the firewall policy. You will configure the default inspection policy to allow ICMP in step 3 of this part of the activity. Okay, here we go. For application layer inspection and other advanced options, the Cisco MPF is available on ASAs. The Packet Tracer ASA device does not have an MPF policy map in place by default. As a modification, we can create the default policy map that will perform the inspection on inside to outside traffic. When configured correctly, only traffic initiated from the inside is allowed back into the outside interface. You will need to add ICMP to the inspection list. Create the class map, policy map, and service policy. Add the inspection of ICMP traffic to the policy map list using the following commands. Class map, okay, conf t, class map, inspection, default. Alright, match default inspection traffic, exit policy map, global underscore policy, class inspection underscore default. Okay. Inspect ICMP, exit, service policy, global policy, global. Boom, boom, boom. Jumped us up to 60%. From PCB, attempt to ping gig 00 interface again And now it works. Okay. Configure a DHCP address pool and enable it on the ASA inside interface. Alright, so DHCPD address 192.168.1.5 through 192.168.1.36 inside. Specify the IP address of the DNS server to be given to the clients. Alright, DHCPD DNS 209.165.201.2 interface inside. Enable the DHCP daemon within the ASA to listen for DHCP client requests on the enabled interface or the inside interface. Okay, so DHCP enable inside. Define a local user named admin by entering the username command. Username admin. What do we have here? Password admin pass. Alright, configure AAA to use the local ASA database for SSH user authentication. Alright, AAA authentication, SSH console, local. Alright, the ASA can be configured to accept connections from a single host or a range of hosts on the inside or outside network. In this step, hosts from the outside network can only use SSH to communicate with the ASA. SSH sessions can be used to access the ASA from the inside network. Generate an RSA key pair, which is required to support SSH connections. Because the ASA device has RSA keys already in place, enter no when prompted to replace them. So that's important right there. Enter no when prompted to replace them, because otherwise we'll lose points instead of getting new points. So crypto key generate RSA modulus 1024. Do you really want to replace them? No. Okay. Configure, normally we would if we were doing this, or actually wouldn't ask us because we would be making new keys instead of replacing keys that were already there. So configure the ASA to allow SSH connections from any host on the inside network 192.168.10/24 and from the remote management host at the branch office 172.16.3.3 on the outside network. Set the SSH timeout to 10 minutes. The default is 5 minutes. Alright, so SSH 192.168.1.0/24 inside SSH 172.16.3.3. We want that exact host, so we're going to say 255.255.255.255 or /32, meaning this host only. Outside SSH timeout 10 minutes. Alright, we're up to 72%. Let's go to PCC. Command prompt SSH-L admin 209.165.200.226. Look at that. Admin PA55, and we're in. Now let's try it from PCB. SSH-L 192.168.1.1, and I need to put the admin in there. Admin PA55. Admin PA55. There it is. Cisco in PA55. Nice. Log out. Doesn't. Okay. Log out. Already back to the PC. Okay. Router 1 gig 00 and the ASA outside interface already use 209.165.200.225 and 226 respectively. You will use public address 209.165.200.227 and static NAT to provide address translation access to the server. Configure demilitarized zone VLAN 3, which is where the public access web server will reside. Assign it to IP address 192.168.2.1/24, name it DMZ, and assign it a security level of 70. Because the server does not need to initiate communication with the inside users, disable forwarding to interface VLAN 1. Okay. So here we go. Interface VLAN 3. IP address 192.168.2.1. No forward interface VLAN 1. Name if DMZ. Set to 0 by default, but we don't want that. We want security level 70. Alright, 86%. We're getting close. Assign ASA physical interface E02 to DMZ VLAN 3 and enable the interface. Alright, so interface Ethernet, why isn't it? Ethernet 02. Alright, I guess we're in there. Switch port access VLAN 3. Okay, I guess that worked. I don't really know because we didn't go up at all. Use the show interface IP brief command to display stats for all. Okay, so show interface IP brief. VLAN 3 is up. It's got the right IP address. Cool. Show IP address just so we can see what everything is. Yep. Got the right IP address. Cool. Show switch VLAN. Yep, we put Ethernet 02 on DMZ VLAN 3. It's up. Good to go. Alright, configure a named access list. Oh wait, not quite yet. Configure a network object named DMZ server and assign it the static IP address of the DMZ server. 2.3. While in object definition mode, use the NAT command to specify that this object is used to translate a DMZ address to an outside interface using static NAT, and specify a public translated address of 209.165.200.227. Okay, so object network DMZ server. Oops, gotta back out. Object network DMZ server host 192.168.2.3 NAT DMZ outside static 209.165.200.227 and exit. We're up to 93%. We're close. I'm betting this will get us to 100 right here. Configure a named access list outside DMZ that permits the TCP protocol on port 80 from any external host to the internal IP address of the DMZ server. Apply the access list to the ASA outside interface in the in direction. Okay, so access. Oh wait, I need a conf t. Access list outside dash DMZ permit ICMP any to host 192.168.2.3. So that means access list named outside DMZ. We want to permit ICMP packets from anywhere to the host at 192.168.2.3. All right. Access list outside dash DMZ. Now we're going to permit TCP packets from any host to the host at 192.168.2.3 if that TCP packet is on port 80. And access group outside dash DMZ in interface outside. Boom, 97%. Okay. Unlike iOS ACLs, the ASA ACL permit statement must permit access to the internal private DMZ address. External hosts access the server using its public static NAT address. The ASA translates it to the internal host IP address and then applies the ACL. At the time this packet tracer activity was created, the ability to successfully test outside access to the DMZ web server was not in place. Therefore, successful testing is not required. Your completion percentage should be 100%, but it's not. So what did we do? Let's find out. Check results. Assessment items. What are we missing? DHCP client enable on Fast Ethernet 0. Oh, they didn't tell us to do that. That's cool. So on PCB, go to IP config and hit DHCP. Boom, 100%. All right, there you have it. That is how you do this lab.